Welcome everyone to our new topic today, indices and logarithm, based on the SSCE syllabus. We'll be taking the aspect that has to do with indices first of all, and we start with the laws of indices. 1. X raised to power A times X raised to power B is equals to X raised to power A plus B. But X raised to power A times Y raised to power B is not equals to X raised to power A plus B. Examples on simple application. 3 raised to power 5 times 3 raised to power 1 is equals to 3 raised to power 5 plus 1. That is 3 raised to power 6. But 3 raised to power 5 times 2 raised to power 1 is not equals to 3 raised to power 5 plus 1. 2. That is II. 7 raised to power 2 times 7 raised to power 2 is equals to 7 raised to power 2 plus 2 in powers. That is 7 raised to power 4. But note, 7 raised to power 2 times 8 raised to power 2 is not equals to 7 raised to power 2 plus 2. Let's take another law. 2. X raised to power A divided by X raised to power B is equals to X raised to power A minus B. Or it can be presented as X raised to power A in fractional form over X raised to power B is equals to X raised to power A minus B. Examples on simple application. 2 raised to power 4 divided by 2 raised to power 3 is equals to 2 raised to power 4 minus 3. That is 2 raised to power 1. Another example, 5 raised to power 3 divided by 5 raised to power 1 is equals to 5 raised to power 3 minus 1. That is 5 squared. Let's take another example, simple application. 3, I. In fractional form, 3 raised to power 4 as the numerator divided by 3 raised to power 2 as the denominator is equals to 3 raised to power 4 minus 2. That is 3 squared. Let's take another law. Law number 3. X raised to power 0 is equals to 1. Examples on simple application. 2 raised to power 0 is equals to 1. 10 raised to power 0 is equals to 1. Open bracket 4 square bracket close raised to power 0. 3 bracket open 4 square bracket close raised to power 0 is equals to 1. Another law, number 4. X raised to power minus A is equals to 1 over X raised to power A. And a further illustration of that law, we have bracket open Y over X bracket close raised to power minus 1 is equals to X over Y. Also, bracket open 1 over X bracket close raised to power minus A is equals to X raised to power A. The most common one is X raised to power minus 1 is equals to 1 over X. Or bracket open Y over X raised to power minus A is equals to bracket open X over Y bracket close raised to power A. Examples on simple application. 10 raised to power minus 2 is equals to 1 over 10 squared. Another example, II. Bracket open 4 over 5 bracket close raised to power minus 2 is equals to 5 over 4 bracket open and close raised to power 2. Another example, a simple application, bracket open 1 over 100 bracket close raised to power minus 2 is the same as 100 squared. Another law, bracket open X raised to power A close bracket raised to power B is the same as X raised to power AB. Example on simple application, bracket open in the first one, 2 raised to power 3 bracket close square is equals to 2 raised to power 3 times 2. That is 2 raised to power 6. Another example, bracket open 5 square, bracket close, square is the same as 5 raised to power 2 times 2. That is 5 raised to power 4. Another law says s raised to power 1 over a is equals to root a of x. Example on simple application. 16 raised to power half 1 over 2 is equals to square root of 16. 27 raised to power 1 over 3 is equals to cube root of 27. 3. 10,000 raised to power 1 over 4 is equals to fourth root of 10,000. Another law. S raised to power b over a is equals to root a of x. Then bracket close, raised to power b. Let's take a simple example then. 4 raised to power 3 over 2 is the same thing as square root of 4, bracket open and close, to the power of 3. Another simple example, 125 raised to power 2 over 3 is equals to, bracket open, cube root of 125, close your bracket and square. The given examples on simple application were not fully solved. It is intentionally done to allow for step-by-step understanding of the laws. Examples. We'll be treating some of these problems to digest, understand better the principles we have stated, the laws we have stated. And these examples are taken, the laws and the examples are taken from page 74 of our hidden fact in SSCE mathematics. Simplify, bracket open 1 over 4, bracket close, raised to power minus half. The options are given. A, minus 1 over 2. B, 1 over 4. C, 1 over 2. D, 2. E, 4. Solution. Applying Indices law, bracket open 1 over 4, bracket close, minus 1 over 2 is equals to, bracket open 4, then bracket close, raised to power 1 over 2. And that is equals to 2. In natural sense, we have just taken the square root of 4. Another example. Find the value of 8 raised to power minus 2 over 3. A, 1 over 2. B, 1 over 4. C, 1 over 8. D, 1 over 16. Solution. Applying the laws of indices. 8 raised to power minus 2 over 3 will be equals to 1 over 8 raised to power 2 over 3. And that is equals to 1 over, we now open a bracket for the 8 because we are seeking to express 8 in terms of powers that will cancel out the denominator of the power it was expressed. So 8 can be expressed as 2 raised to power 3. So open up the bracket there, 2 raised to power 3. Then you close the bracket, it's raised to power 2 over 3. The 3 in the power of 2 will cancel out with the denominator in the power there. So those 3 will cancel out and will be left with equals to 1 over 2 squared. That is the same as 1 over 4. Another example. Evaluate, bracket open 0.008, bracket close, 1 over 3. The options are given. A, 0.15, B, 0.8, C, 0.5, D, 0.2, E, 0.1. Solution. We can express 0.008 raised to power 1 over 3 to be the same as 8 over 1000 raised to power 1 over 3. Now we raise items inside a bracket to power 3 to cancel out the root 3 outside. And that will give us 8 will now be 2 raised to power 3. 1000 will now be 10 raised to power 3. We open our close our bracket. Everything inside the bracket still raised to power 1 over 3. And that will give us, since we have achieved root power of 3 to be cancelling out the root 3, we now have 2 over 3. We can easily express it as it is shown there. That is equals to 2 over 10 raised to power 3 over 3. That is because everything inside the bracket, then we've been able to raise them to power 3. So we can equate our answer as this. And that will give us 3 will cancel out, and you have 2 over 10. And 2 over 10 is the same as 0.2. Another example, simplify, bracket open, minus 8, bracket close, raised to power 4 over 3. The options are given. A, minus 32. B, minus 16. C, 16. D, 32. Solution. The power 4, which is even, we cancel the minus sign. Thus, bracket open, minus 8, bracket close, raised to power 4 over 3 is the same as bracket open 8, bracket close, 4 over raised to power 4 over 3. So what we are saying, virtually 2 of them are the same thing, because the operation of the power of 4 we cancel out. Since it's even, we cancel out the minus sign. And we will now seek to raise 8 to power of 2, because we try to raise 8 in a such a way that it will has the same power as the numerator, which is 3. And that will be equals to 2 cubed raised to power 4 over 3. And once that has been achieved, the power of 3 will cancel out the root of 3. And that will be equals to 2 raised to power 4, which is 16. Another example. The value of bracket open 4 raised to power 1 over 4, bracket close, raised to power 6 is the options. A, 1 over 8. B, 4. C, 6. D, 8. Solution. What this question simply means is that 4 raised to power 1 over 4, bracket open and close, raised to power 6 is the same thing as 4 raised to power 6 over 4. And with that, we can simply reduce the powers to be the same as equals to 4 raised to power 3 over 2. It is allowed. Powers can reduce to that. And once that has been achieved, we can now seek to make 4 in power of square to be able to cancel out the root power 2 of root outside. 4 is the same thing as 2 square, bracket open and close, then you have 3 over 2 in power. And the 2 inside the power of 2 will now cancel out the root 2 outside. And that will give you equals to 2 raised to power 3, which is equals to 8. Another example. Simplify 125 raised to power minus 2 over 3 times 15. The options are A, 1 over 25, B, 3 over 25, C, 1 over 5, D, 3 over 5. Solution. 125 raised to power minus 2 over 3 times 15 is the same as 15 over 125 raised to power 2 over 3. Now we seek to raise the denominator in power of 3. That is 125 in power of 3. Because once you are seeing root 3 there, it should give you a signal that we can raise 125 to power of 3. That will be equals to 15 over 125 become 5 raised to power 3. Then bracket close raised to power 2 over 3. Remember, the powers will now multiply out, and when they multiply out, 3 will cancel out 3. And that will be equals to 15 over 5 squared. And expressing it in a better form, we know that 15 is the same as 3 times 5. And 5 squared is 5 times 5. So 5 will cancel out, and you have solution to be 3 over 5. Another example. Simplify, bracket open, 1 over 16, bracket close, raised to power minus 3 over 4 plus 5 into bracket open, 9 raised to power 0, bracket close. Solution. Applying indices laws, we have that our given problem, which is 1 over 16, bracket open and close, raised to power minus 3 over 4 plus 5 into bracket open, 9 raised to power 0, bracket close, is equals to 16 raised to power 3 over 4 plus 5 times 1. Recall that in the law, anytime we have anything raised to power minus, if it's a fraction, it becomes a whole number. And we have also said in one of the laws that anything raised to power 0 is 1. So hence, your expression gave us that result. Next, when you look at the 16 and the root of 4, it will simply give you a secret that 16 can be expressed to power 4. So we express 16 in power that will cancel out root 4. And that will give us equals to 16 will now be 2 raised to power 4 bracket open and close, then 3 raised to power 3 over 4 plus 5 power 4 inside the bracket, cancel out with the root 4 outside the bracket. And that will give us 2 raised to power 3 plus 5. And that is 8 plus 5, which is 13. Another example. Evaluate 2 divided by bracket open 64 over 125 bracket close raised to power minus 2 over 3. Solution. Applying the laws of indices for minus power, we have that our given problem 2 divided by bracket open 64 over 125 bracket close raised to power minus 2 over 3 is equals to 2 divided by bracket open 125 over 64 raised to power 2 over 3. As we remove the minus sign, denominator becomes numerator in the fractions inside the bracket. Next, we seek to express the bracket item in power 3 that we cancel out root 3 outside it, which is equals to 2 divided by 5 raised to power 3 over 4 raised to power 3 bracket close raised to power 2 over 3, which is equals to 2 divided by 5 over 4 bracket open and close. Since the numerator and denominator are now in the same powers of 3, we can bring out factor out the power, become 3 times 2 over 3, and that is equals to 2 divided by 5 over 4 bracket open and close raised to power 2 equals to 2 divided by 25 over 16, which is the same as changing from division to multiplication 2 times 16 over 25, and that is the same as 32 over 25. Another example. Without using mathematical tables or calculator, simplify 16 raised to power half times 8 raised to power minus 4 times 3 raised to power minus 2 over 3 divided by 81 raised to power minus 2 over 3. Solution. Express the items in 3 and 2 with their power. Thus, 16 raised to power half times 8 raised to power minus 4 times 3 raised to power minus 2 over 3 divided by 81 raised to power minus 2 over 3 will be equals to 2 raised to power 4 bracket open and close then raised to power half times 2 raised to power 3 bracket open and close raised to power minus 4. That is, we have transformed 8 to become 2 raised to power 3 times 3 raised to power minus 2 over 3 divided by 3 raised to power 4 bracket open and close raised to power minus 2 over 3. In the case of the first 4, 2 will cancel out, denominator will cancel out in the power, so we'll be left with 2. So you have 2 raised to power 2 times, you will now have 3 times the powers will multiply each other, and that will give you 12 times 2 raised to power minus 12 times, in case of 3 raised to power minus 2 over 3 still remain as it is. Then divided by, for the last one, you multiply the powers. So that is why you now have divided by 3 raised to power minus 8 over 3. Applying the laws of indices, we can simply now say the 2's, the ones in power of 2, we take them together. So it will now be 2 raised to power 2 minus 12 times the 3's, we now go together. 3 raised to power minus 2 over 3. Division is minus, so minus, then you open bracket to accommodate what you have there before, minus 8 over 3. Close the bracket. And 2 will be raised to power minus 10, because 2, the power 2 minus 12 is minus 10. So that's why you have 2 raised to power minus 10 times 3. When you open up the bracket, the minus become plus. So we now have minus 3 raised to power minus 2 over 3 plus 8 over 3. We still go further in the simplification. That will give you 2 raised to power minus 10 times simple arithmetic operation of the fractional power will give you times 3 raised to power 6 over 3. And that will be equals to 2 raised to power minus 10 times, if we have 6 over 3, they can cancel out, and that will give you 3 raised to power 2. And that will now give us 9. Remember, minus power, we take it to the denominator. So 3 squared will now be 9. And once 2 raised to power minus 10 come to the denominator, it becomes power 10. So it becomes 2 raised to power 10. And that will also give us 9. Our final answer will be 9 over 1024. Another example. Simplify. We have a fraction now. The numerator 25 raised to power 2 over 3 divided by 25 raised to power 1 over 6. That's the numerator. Then we'll go to the denominator. You have bracket open, 1 over 5, bracket close, raised to power minus 7 over 6, times bracket open, 1 over 5, bracket close, raised to power 1 over 6. The options are given: A, 25, B, 1, C, 1 over 5, D, 1 over 25. Solution. When you look at the numerator and the denominator carefully, you will now realize that you can express all the items in terms of 5 and its powers, so that our problem, which is the numerator 25 raised to power 2 over 3 divided by 25 raised to power 1 over 6 over bracket open 1 over 5 raised to power minus 7 over 6 times bracket open 1 over 5 bracket close raised to power 1 over 6 will be equals to 25 become 5 squared as the numerator raised to power 2 over 3 divided by 5 squared. Again, you open and close your bracket, raised to power 1 over 6. That's the numerator. The line will go to the denominator. 1 over 5 will become 5 raised to power minus 1. Open and close your bracket, raised to power minus 7 over 6 times 5 raised to power minus 1, bracket open and close, raised to power 1 over 6. That is the same as equals to, our numerator will now have the powers. 2 times 2 will now give you 4 powers of 5 at the numerator. So, and that will give you the first 5, that will be 5 raised to power 4 over 3. And the other 5 will now give you, we're now having divided by 5 raised to power 2 over 6. Because the 2 will multiply 2 times 1 over 6 will become 2 over 6. Then at the denominator, minus times minus power will cancel out to become plus. So we now have 5 raised to power 7 over 6 times, when minus in the other value at the denominator, minus 1 times 1 over 6 in the power will become 5 raised to power minus 1 over 6. Now, applying indices laws, we now have equals to, at the numerator, since they are the same base now 5, so we now have 5 raised to power 4 over 3. Division is minus, so in powers, so we now have minus 2 over 6. Then the denominator, rule our line, I will go to the denominator. It will be 5 raised to power 7 over 6 plus 6 is multiplication, so that's why we introduce the plus there. But remember, the power of the other 5 is raised to power minus 6, so we introduce a bracket to safeguard it. Bracket open minus 1 over 6, which is equals to, we do our simple fractional operation in the powers. That will be equals to 5 raised to power, at the numerator, 5 raised to power 8 minus 2 over 6. Then we go to our denominator, it will be 5 raised to power 7 minus 1 over 6. Remember, we are applying simple operation of fraction to the indices, which is equals to 5 raised to power 6 over 6 at the numerator over 5 raised to power 6 over 6 at the denominator. The value are the same, both denominator, so they can cancel out and give you final answer as 1. We've come to the end of this subtopic. Next, we take some exercises from our book at page 76 in Hidden Facts in New SSCE Mathematics. Try your hands on these exercises. The answers are given at the last part of this book, either the soft or the hard copy. Thank you.